So the next part, they are going to talk about the motion in one dimension, the motion diagram. Okay, now the motion diagram is actually your number line.
Mm.
The number
Sorry.
line, something like this, right? Then they will show the arrow there. So the arrow, the red color arrow represents the velocity, and this purple
Mm-hmm.
color, purple color arrow, it represents the acceleration. And they are at different position along the number line. They are at different position along the number line. Okay.
Okay.
Now, let's say they are equally spaced out like this. They are equally spaced out. And can you see they are all equally spaced out like that?
Yep.
They are all equally spaced out. So that means that position, the position, let's say if this is 10 meters, so they are always 10 meters apart. They are always 10 meters apart. This is 10 meter, this is 10 meter. So probably in the number line, this one is 0, 10, 20, 30, 40, and 50 along the number line. Okay, right. So what can you say about the velocity if they are equally spaced out like that? Now, have you
Mm.
in play with this ticker timer and ticker tape? You see, you put a
No.
trolley there, the trolley, you attach the ticker tape there, then you let the
I don't
trolley
think so.
run, then you will pull the ticker tape along, and they will make certain mark on the ticker tape. And this mark, they are equally spaced out. So if this mark, they are equally spaced out, what can you say about the velocity? They are equally spaced out like that. Or if you look at the second case, if you look at the second case, uh, at first the distance is smaller, then it becomes bigger and bigger and bigger. The spacing between the car there, the spacing between the car become bigger and bigger and bigger. What can you say about the velocity in the second case? Or you see at first the spacing between them is very big, then finally the spacing between them becomes smaller and smaller. So what can
Mm-hmm.
you say about the velocity in these three cases?
Uh, going slower or further away.
Okay, now let's say it takes 1 second to move from the first position to the second position. So one
Mm, okay.
second to move from the first position to the second position. So it is 10 meter in 1 second. This one is 10 meter in 1 second, 10 meter in 1 second, 10 meter in 1 second. So what can you say about the velocity? Is the velocity increasing?
Yes.
No, because
Eh,
all
10
the
meters in
time
1 second. No,
10,
no, no,
10,
no,
10.
no. Constant.
No. So what is the velocity? Is it constant, increasing,
Constant.
or decreasing? Constant, because all the time 10
Constant.
meter in 1 second, 10 meter per second, 10 meter per second. So equal spacing means the velocity is constant. If the velocity is constant, what can you say about the acceleration? What can you say about the acceleration if the velocity is constant? So when the velocity is constant, I better underline.
Acceleration is 0.
Ah, yes. When the velocity is constant, the acceleration is 0. Okay. Now, if you look at the second case here, the spacing increases, increases, increases. They become further and further apart. What can you say about the velocity? Is it increasing or decreasing or constant? This one, the second case here. The spacing here is increasing, increasing, and even more.
increasing,
So what can you say about the velocity?
accelerating.
Okay,
Our velocity, it will be increasing. No? Not, how
more
would
and
you?
more. So the velocity
Okay,
is what?
increasing.
More and more. Let's say here is let's say 2 meters. Here become 8 meters in 1 second. Here 10 meters in 1 second. And finally is 12 meters in 1 second. So it means the velocity is increasing every
Mm-hmm.
second because the distance covered become more and more. So the velocity is
Yep.
more and more, right?
Mm-hmm.
So if the velocity is increasing, we say that there is an acceleration, positive acceleration or negative acceleration,
Positive.
positive acceleration. So the car increase the velocity and it has a positive acceleration. Now in the last case here, what can
Mm-hmm.
you say about the velocity of the car? At first the space is very big, then the
Is
spacing become
decreasing,
less and less. What about the velocity? The velocity
decreasing,
is what?
less and less, decreasing more,
Increasing or decreasing?
decreasing.
Yes, the velocity is decreasing. The velocity is decreasing means deceleration or negative acceleration. Okay, so this is the type of diagram. Actually, this diagram here it shows the position, position versus time, position versus time. So if the velocity is constant, then we say that the acceleration is zero. If the velocity is increasing, then we say it is a positive acceleration. If the velocity is decreasing, then we say it is a negative acceleration.
Yep.
Okay, so we clear this. Okay, right. Now, over here, we have three different graphs. They show the position versus time. It's not the velocity versus time, but it is the position versus time. Now, which of this graph is impossible? Which of this graph is impossible?
B.
Correct, it is B. Why is it B? Because let's say this is the time, right? This is the time, then you can have two different
Two
velocities at
different
the same time.
velocities.
One velocity here and another velocity here. The same time you have two different velocities. So this is
Mm-hmm.
impossible, right? Uh, the next one. Okay, next one. Huh? Next one, uh, figure 2.14. Where is it? Ah, this one they are referring to. You read and see figure 2.14.
It's a diagram of multi-flash image of an air puck moving to the right on a horizontal surface. The image sketch are separated by equal times intervals, and the first and last images show the puck at rest. In A, figure 1.2.14, which color graph best show the puck position at a function of the time? In B, which color graph best show the puck velocity as a function of time? C, which color best show the puck's acceleration as a function of time?
Okay. Oh, never mind. This one show. Okay, right. Now, we talk about this diagram here, the part A of the diagram. It is
Mm-hmm.
not part A of the question. Part A of the question is referring to the graph B. Part B of the question is referring to the graph C. And part C of the question is referring to the graph D. Is here, right? It's referring to
Yep.
graph D. So they didn't say anything about the A here. So from your knowledge, just now over here, right? Over here, the spacing, by looking at the spacing, can you describe the motion? Now these dots
It
here,
is.
they are actually the different position, right? The different position of an object. So at first you see the dot here very close together, then they become further apart, further apart. Then this one, same distance, same distance, same distance, then become shorter and shorter. So by
Mm-hmm.
looking at the position and you refer back to the three cases here, what can you say about the motion of the object?
It's increasing, then it becomes constant, then it decreases.
Yes, yes, very good. So it means now you know that it is increasing velocity, constant velocity, then decreasing velocity, right?
Okay.
Okay, right. Now, knowing the, with this knowledge of the motion of the object, can you imagine how the position time graph, velocity time graph, and the acceleration time graph looks like? How do you know how the graphs look like? First one. The first one
Okay.
is position versus time. Position versus time. So which of these three lines, the red line, then drop back, then the blue line is a very smooth one, and the green line, then think like that. So which of these three lines shows the motion of the object, which is described by this A here? Position time
Green.
graph.
Okay, no, cannot.
The blue line, the green line, or the red line?
Eh, red.
The red line means the position go further, further, then drop back again. You go
Mm-hmm.
there, then you come back again. So
Yeah.
this one doesn't show that it come back, you know. You just go further and further and further, further, further. You never come
Then it
back.
has to be
So
blue.
this one shows that it drop, come back. So it
Blue.
cannot be the red line. Okay,
Okay.
now which line? You choose blue or green?
Blue.
Huh?
Blue.
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 Okay, it is the blue line. Okay, it's the blue line. You see that the position at first it is going right further and
Mm-hmm.
further apart. Now this part here, then it curves back again, become less and less
Okay.
again the position. So in between here they space out very well. Towards the end there is very close together, and towards this end also very close together. So it's actually the blue line is correct, right? So let us see what here is written here. Okay, blue line shows the position versus time graph. The slope shows the instantaneous velocity from the start, then zero increases, then flatten to zero again. So you see the what is it? The slope of the tangent. So the slope of tangent actually is zero here. Then finally you come until the end here, the slope is also zero, right? So the blue line actually represents this movement of this object. Now, part C here. Which of these three lines, the red, the blue, and the green, which of it shows the velocity of this object here? Which line shows the velocity of the object?
Velocity. Red.
The red line. Now, the red line, you see, earlier you
It
told me here
increase.
the velocity increases, then constant, then decreases
Constant,
again.
then
So you
decrease.
see here the red line, they move up, the velocity increases, then become a horizontal line, become constant,
Mm-hmm.
then move down again. So the velocity decreases until zero again. So you are right, the red line represents the velocity. Now, again, this one, red, blue, and green. Which line represents the acceleration? Velocity increasing. What is the acceleration?
Mm-hmm.
Positive, negative, or zero?
Positive.
Positive. Okay, it's positive. Velocity constant. What is the
Zero.
acceleration? Zero. Zero.
Zero.
Then velocity decreases. What is the acceleration?
Negative.
Negative. So which line represents the acceleration of this object?
Red. Uh, red, no? No?
The acceleration is positive, zero, then negative. Now which one shows positive, zero, then negative? Now this red line is positive all the time. This red line is positive all the time.
Green. Like positive,
Then
then
the
zero,
the
then
blue
negative.
line, the blue line is positive,
Zero,
no zero,
then
no
negative.
zero, then straight away they jump to negative. The green line,
No zero?
positive,
Oh, okay,
then
okay.
go to zero, then go to negative again.
Oh, okay, okay, okay.
So which line is it?
Green.
Which line represents the acceleration?
Green.
Correct, it is a green line. So we stop here.